Every car accident, every traffic jam, every DUI death, all of it is a software problem. And we have been trying to fix it with better software for decades. Self-driving cars, lane assist, automatic braking, forward collision warning, software. What about the car accidents that the driver was never at fault for? The ones that would have happened to anyone. Their vision gets impaired from the morning sun, glaring through the windshield, hiding the stop sign, or slipping off the road on black ice. What if the hardware is just wrong? What if the car itself, rolling on rubber tires on flat asphalt, is the wrong machine for the job? Because here is the actual problem with cars. At highway speed, a human needs somewhere between 1 and 2 seconds of reaction time to respond to something going wrong in front of them. 1 to 2 seconds at 65 miles per hour is 90 to 190 feet of dead space. Space you need but cannot use. Now, push that to 150 miles per hour, which is completely achievable on a closed track with modern vehicles, and that dead space becomes 400 feet minimum. Per car, that is not a software problem. That is physics. And it gets worse. That dead space multiplies across every car on the road. Traffic jams do not happen because roads are full. They happen because cars need those gaps, and those gaps collapse, and the whole system seizes. 1.5 million people die on roads globally every year. More than wars, most diseases, most things we consider catastrophic. We treat it like weather, just a thing that happens. And the average car carries 1.5 people. That is the 2022 number from the National Household Travel Survey. Not 4 people, not 2, 1.5. A 2-ton machine burning energy to move 1.5 humans. Most of that dead space on the road is empty metal. Self-driving will help. It will cut the DUI deaths, the distraction deaths, the fatigue deaths, the speeding deaths. But self-driving cannot eliminate that reaction gap. But the car still needs space ahead of it, even if a computer is watching instead of a human. The problem is not the driver. The problem is the vehicle. So here is the idea. What if every road was a rail? Not a train, not a bus. Your personal vehicle, your cart, running on a track embedded in every road you use today. You own it or you rent it. The routing is automatic. You get in, you tell it where you are going, and it takes you there. No steering, no pedals, no license required. The car becomes a cart. Now, here is where it gets interesting. If you own your cart, you can do whatever you want with it. You want a hot tub in there, put a hot tub in it. You want a bed for overnight trips, you want a full office setup, you want a shower, you want a home theater. Whatever you can fit in the footprint, it is yours. The cart is your space. It just happens to move. If you rent, it is different. A rental is a box, a seat, climate control, a screen, functional, not luxurious. And that distinction matters, which we will get to in a moment. The fee structure is 3 things. First, road usage. You pay time multiplied by the length of your cart, multiplied by a congestion multiplier based on the road you are on. That last part is important. On a highway outside of Cheyenne, Wyoming, at 2 in the morning, the congestion multiplier is near 0. Roll your 40-foot rolling spa at whatever rate you like. But in downtown Manhattan at rush hour, that multiplier is brutal. Every foot of track your cart occupies is a foot another cart cannot use. The pricing reflects that. Your 40-foot luxury suite in Manhattan during peak hours will cost you significantly per minute. You will want a smaller cart. The market takes care of it automatically. No legislation needed. No mandates, just price. Second fee, white times miles. Your cart weighs more, you pay more. It uses more energy, it puts more wear on the track, you cover that cost. Third fee, electricity. Straightforward kilowatt hours consumed, plus parking, which still exists, plus a rental fee if you are not using your own cart. The system is self-regulating. You are never told what size cart to own. You feel it in your wallet. Now, the mechanical problem. How do turns work? Right turns are easy. Each direction of travel has two parallel lines of track, the inner lane and the outer lane. When you need to exit right, you signal the system. You peel off to the inner lane, decelerate, and the track branches to your exit. The carts behind you on the outer lane continue without interruption. After your turn, you rejoin via an acceleration ramp and merge back to the outer lane at speed. Exactly like a highway exit and on-ramp, just automated. Left turns are the hard problem. There are 3 solutions and the right one depends on where you are. Option 1, the Michigan left. You pass through the intersection, continue on the track, and then enter a dedicated U-turn loop to reverse direction. Then you take your right turn from the opposite side. Already used in parts of Michigan and other places. Works well for high-volume intersections. Option 2, the elevated crossover. A ramp that carries your cart over the opposing track to reach the left-hand branch. Like a cloverleaf interchange but designed for carts. Takes more space but handles high volume. Option 3, the roundabout switching yard. Your cart slows, enters a circular routing hub, and the system switches you to the correct exit. Fully automated, no driver judgment required. Lower volume suburban intersections would use roundabouts. High volume urban intersections would use Michigan lefts or elevated crossovers. The infrastructure matches the demand. Now, getting started. How does your cart get onto the network from your house? Your driveway connects to a low-speed feeder lane. Think of it like a residential road, but on rail, running at neighborhood speed. The feeder connects to the main line. When you are ready to merge, your cart accelerates to mainline speed in an acceleration zone. The system detects a gap in the traffic ahead of you and merges you in. Automatic, but down. Seamless. Torrent in. Same concept as a highway on-ramp, but the merge is not up to you. Now, the part that makes this genuinely different from everything else. Coupling. Coupling. If the cart ahead of you is going to the same destination, or even just the same general direction, the system can connect you. Both carts match speed. Then, a magnetic coupling or a physical latch closes the gap between them. You are now mechanically joined. Add another cart, and another, and another. You have just built a train on demand, made of personal vehicles, with no schedule, no fixed stops, going exactly where you are going. The throughput of a freight train. The flexibility of a car. This is the thing self-driving vehicles can never replicate. You cannot magnetically couple 2 Teslas. The car format does not allow it. But carts on rails do. A 50-cart chain, occupying the space and energy budget of 50 individual vehicles, but moving like a single train. With rigid coupling, you are no longer limited by that reaction gap we started with. The whole chain decelerates together. No gaps needed. That is what enables the speed. Without reaction gaps, without the need for spacing, you can run these systems significantly faster than current highway limit. The physics allow it. The infrastructure sets the ceiling, not human reaction time. Animal crossings are still a real problem, same as trains have. Sensors on the track detect large animals in the corridor. The system slows. The animal clears. The system speeds back up. It is manageable. It is not solved. Same reality trains deal with every day. And on the highest density corridors, you have one more option. Vida tracks, commuter, double-decker, carts, Duffin, side-by-side configurations. In a tunnel under a dense city, doubling the height or width of your carts doubles throughput without adding track. Now the honest accounting. The infrastructure cost is enormous. Every road in the country would need to be dug up and relaid with embedded rail. That is a decades-long project and a multi-trillion-dollar investment. The feeder network is its own problem. Getting rail to every driveway in a suburban sprawl is not a simple task. The last-mile problem does not disappear. Left turns never become as clean as right turns. No matter which solution you choose, they are always more complex, more expensive, more space-consuming. And you cannot go off-road. There is no driving to a trailhead, no exploring unpaved roads, no backing your cart onto a boat ramp. Where the rail ends, you stop. That is the real trade-off. We have been optimizing the automobile for 120 years. We have made it faster, quieter, safer, more efficient. We have built the entire surface of civilization around it. And we still kill 1.35 million people on roads every year. Maybe the car is not the problem to solve. Maybe the road is.